Question 9. A horizontal beam is pivoted at one end. The beam has a length of 15 meters and a mass of 150 kilograms. The center of mass of the beam is located 5 meters from the pivot. Calculate the moment of the weight of the beam about the pivot. As we can see, this is a problem on moments of forces. What we already know, we know that the moment of a force about a point is defined as the product of the force and the perpendicular distance from the pivot to the line of action of the force. We also know that the weight of a uniform beam acts through its center of mass. Finally, unless stated otherwise, the acceleration due to gravity is taken as 9.81 meters per second squared. We get into the main solution now. First, identify the quantities given. The beam has a length of 15 meters and a mass of 150 kilograms. The center of mass of the beam is located 5 meters from the pivot. This distance is the perpendicular distance between the pivot and the line of action of the weight. Next, we calculate the weight of the beam. Weight is given by the equation weight equals mass multiplied by gravitational acceleration. So the weight equals 150 multiplied by 9.81. This gives a weight of 1,471.5 newtons. Now, we calculate the moment about the pivot. The moment equals force multiplied by perpendicular distance. So the moment equals 1,471.5 multiplied by 5. This gives 7,357.5 Newton meters. Rounding appropriately, this becomes approximately 7.4 multiplied by 10 to the power 3 Newton meters. This is our final answer. What did we do? First, we determined the weight of the beam using the relation between mass and gravitational acceleration. Next, we identified the perpendicular distance from the pivot to the center of mass, since the beam's weight acts through that point. Finally, we calculated the moment by multiplying the force by the perpendicular distance. Before we conclude this, let us look at some easy traps here. Some students mistakenly use the full beam length, in this case 15 meters, as the lever arm, instead of the perpendicular distance from the center of mass. Again, students sometimes assume the pivot is at the center of the beam and take the lever arm as half the length without checking, which only works if the beam is uniform and the pivot is truly at its center. To summarize the key points, moments depend on force and perpendicular distances between the force and the pivot, since the moment of a force about a pivot equals the force multiplied by the perpendicular distance from the pivot. The center of mass acts as the point of application of weight, hence the weight of a beam acts through its center of mass. The center of mass is at the geometric center, or the middle, only for uniform objects.